Hello, everyone. I'm Shantanu from Transition Venture Capital, and I'm joined by David, who is the founder of Protonas.
My name's David De Vries, and I'm the founder of Protonas.
What is a fuel cell? And you mentioned a methane reformer.
So just think battery, and you'll understand a fuel cell. You got a
Got it.
plus, you got a minus. And if you want a lot of voltage, these put out maybe 0.6, 0.8 volts. That's not a lot of voltage. So if you want to have a lot of voltage and a lot of power, you have to make a stack of these. Each one, 0.6 volts, 0.6 volts, 0.6 volts. So if you want 12 volts, you might need like 20 of these plates.
Right, there are a bunch of other companies that are doing this. Various types of fuel cells have been doing it for the last 30 years. The industry, the technology itself could be about 50 years old. So what makes Protonas unique? Why is this any different from what's already out there in the market today?
The coating can cost anywhere from $1 to $3 for a plate like this. Truck fuel cell stack can have 500 of these plates. So that's $1,500 just for the coating. So that's expensive.
Of course.
We think we can do the coating for about 10 cents a plate.
Hello, everyone. I'm Shantanu from Transition Venture Capital, and I'm joined by David, who is the founder of Protonas. And today we're going to talk about the hydrogen fuel cell industry. Hydrogen fuel cells, how do they work? What is the technology behind hydrogen fuel cells? What is the market like? What do you see as the market for the future of hydrogen fuel cells? So let's start. Thank you, David, for joining us today. Start with telling us about yourself, your background, your experiences, the last 20, 30 years.
Sure. My name's David De Vries, and I'm the founder of Protonas. I started my studies in school were working on electrical engineering, and I got my master's degree and almost got my doctorate, but not quite. And that was at Washington State University. And one of my first jobs was working for a little startup called Avista Labs in Spokane, Washington. And that was a startup fuel cell company. And I helped them develop basically the world's first commercialized air-cooled fuel cell. And so it was a fun time with a small group of engineers, young people. And we were able to make a product. And they're still selling those fuel cells as part of Plug Power. And so it was really exciting to work on something that went from the laboratory into the commercial product. In 2001, I decided to start my own company.
What year did you join the earlier startup?
1996.
Wow.
Yeah,
So you've been working on hydrogen fuel cells for close to 30 years now.
Yeah, 29.
29,
So,
yeah.
Yeah, it's been a lot of time in the industry. So we've seen a lot of things. So yeah, in 2001, I thought, I'm going to make my own company, and I'm going to work on something called methanol reforming. And methanol reforming converts methanol into hydrogen, so a fuel cell has a supply of hydrogen from a liquid. And so I worked on that for quite a while. One of the things we also did during that time, we got a contract with the California fuel cell company called Altergy Systems. And I helped develop their fuel cell as a contract, and they took my design and commercialized that, and that was the foundation for their product for 15 years. So I actually designed 2 commercial fuel cells for other people, but it was very gratifying. And in 2015, I ended up selling the company to Horizon Fuel Cell Technologies, and I actually went down to Shanghai and helped them with the tech transfer. And so the methanol reforming technologies became part of Horizon Fuel Cell. And so that was exciting, going to Shanghai and working with the team there for almost 2 years. So after that, I ended up working for Altergy Systems in California for about 5 years. And we worked on a large methanol reformer and also on their fuel cell systems. And their market was backup power. So got very familiar with the backup power market in California and in the US and in different places. and working with the technology for that. So around 2021, I moved to Southeast Asia, predominantly because I really felt like that would be a good pace to resituate myself and offer my services in an area of the country, or in countries where there wasn't a lot of fuel cell activity, because Southeast Asia is not a huge hub for hydrogen. China is, but not Southeast Asia. So I actually ended up taking a position with Hydrogen Energy in Singapore as the CTO, and then I was moved up to the CEO position. And I built a team of maybe 20 people, mostly from scratch, and helped them develop the fuel cell product, a smaller air-cooled system, and then also worked with their team that does coatings for fuel cells. And so that was my experience. And then about a year ago, I started this company as a startup because I really felt like it was time to do another company. So this is my second company that I'll have been a founder of.
And that's very impressive. 30 years of experience in the fuel cell industry, in and around, in various sizes. And before I talk more about that, give us a quick 101. What is a fuel cell? And you mentioned a methane reformer. What is a fuel cell? What does a fuel cell do? How does it work? What does a methane reformer do? How does it work? How are they interlinked? Give us a little bit of an understanding of what types of systems are these? How do you size them? Is it sized in kilowatts?
Sure. The best way is to show you. This right here is the heart of what is called a PEM fuel cell. And you can see there's a little piece of plastic here, and that plastic is acid. It's actually a plastic with acid pieces on it, so it works like an acid. And then on each side, you've got platinum and carbon on both sides of this. Now, I want you to imagine a fuel cell works just like a battery, okay? A lot of you know a battery has a plus and it's got a minus, and in between, you've got acid, okay? So this has acid too, but it's in a plastic form. With the battery, what happens when you run the current through the battery, the chemicals inside the battery get used up. And so as you draw current from the battery, eventually it dies. The beauty of a fuel cell is it's basically like a battery, but you keep pumping the chemicals in on a continual basis. So the battery never dies as long as you put chemicals in. So imagine this is a battery with a plus and a minus. And on one side, I've got hydrogen, and on the other side, I've got oxygen from air. And these are the two chemicals in my battery or fuel cell. And I'm going to keep pumping those in continually. And so that's going to run as long as everything holds up and as long as I supply the chemicals. So just think battery, and you'll understand a fuel cell. You got a plus, you got a minus. And if you want a lot of voltage, these put out maybe 0.6, 0.8 volts. That's not a lot of voltage. So if you want to have a lot of voltage and a lot of power, you have to make a stack of these. Each one, 0.6 volts, 0.6 volts, 0.6 volts. So if you want 12 volts, you might need like 20 of these plates. And so this is called a stack. And you stack the parts up. Each one of these is a polymer electrolyte membrane, PEM. And you stack these up, and then you get lots of voltage and lots of power. Now, we need to get the air in and the hydrogen in on each side of these. And so we have something called a bipolar plate. This is a small bipolar plate for a smaller air-cooled fuel cell. And you can see here we would have a channel for air to come in, and it goes in these little holes and goes down the channels and then comes out over here. And then the opposite side would have hydrogen coming in, and those would go into the channels. So you can see these channels, everything comes on one side as hydrogen. On the other side, you've got the oxygen. And then this plus the fuel cell part in between, those all go into a stack. And on the ends of those, we're going to squeeze them together with something called an end plate. And here we cast these fairly inexpensively. And so those goes on the end, and then you'll have rods that squeeze them. And that's a fuel cell stack. It's actually pretty simple. like I said, if you understand a battery, you fundamentally understand a fuel cell stack.
So making it extremely simple, a fuel cell is something that where you pump in hydrogen and you get out electrical energy in various voltages or currents, depending on your stack size, depending on your stack configurations.
That's right. So you can make these plates really large for like a truck application, or you can make them small for like a backup power application. So it just depends on what you're going to use the fuel cell for. Now you had mentioned the methanol reforming.
So before we go there,
Yeah.
You mentioned PEM fuel cell. So what is a
Yes.
PEM fuel cell? What other types of fuel cells are there?
Sure. There are different kinds of electrolytes. This is a polymer electrolyte membrane. It's super popular because you don't have any liquid. You can do this with molten carbonate at high temperatures. You can do it with KOH, an alkaline fuel cell. So it just depends what kind of electrolyte you want. But the most popular one has really been the PEM because it's just it's something that's easy to commercialize. You don't have these liquids. It's the simplest form of a fuel cell. So this is why PEM is kind of the dominant form of fuel cells. Yeah.
What other forms are there of fuel cells apart from PEM?
Well, you have molten carbonate, you have alkaline, and they're actually trying to get the alkaline into a plastic form with some success. You have a solid oxide fuel cell, and that's where your electrolyte is actually a piece of ceramic, and you get it super hot, and it conducts the oxygen through the ceramic membranes. Those are a lot more expensive, harder to build.
Okay.
Yeah.
Okay. So broadly, what are the advantages, disadvantages here? Why would you pick a PEM versus a carbonate or versus an alkaline? And how do you sort of rate these? I mean, is it power? Is it life cycles? Obviously, because it's one continuous energy output. Is it number of hours? Is it efficiency? What are the key parameters that someone uses to sort of rate a fuel cell? And how do you compare the various technologies? And then finally, why did you start selecting PEM to work on?
Sure. With solid oxide, the temperatures typically are 600 to 800 Celsius. I mean, it's literally glowing hot. And it takes a long time for those to warm up. And they don't like cooling and heating because they're ceramics and you can crack them. So those don't like to start and stop, and they don't like to do it quickly. So if you want to have a car or a bus or some kind of application, the PEM, it runs close to room temperature, and so it's going to start right away. And a lot of these other technologies either require a high temperature or they've got this liquid electrolyte that don't really suit them for making a small, compact, fairly cost-effective solution. So PEM has been the winner here, and it's taken some time and improvement technically for the PEM over the years. That thin plastic membrane, it used to be thicker, but they figured out over the last 20 years how to make it thin, how to reinforce it. And by making it thin, you get a lot more performance and a lot of other advantages. And so these are just some of the areas where the technical development over the last 20, 30 years has allowed us to make a system out of these membranes that's much more effective than it would have been like when we started in 1996.
So you've been in the industry for close to 30 years now. Fuel cells, as I know it, is not a new technology. It's not a new thing. It's been around for, I would say, at least 50 years, maybe more. And you've seen the progression. You've seen most of the progression of the industry. What do you think were some of the key challenges or some of the key insights that you learned from this industry, from a tech perspective, from a market perspective, from a product perspective, from a cost perspective? What do you see as the challenges blocking this industry?
Well, a lot of the challenges we've seen over the last 30 years, the amount of platinum it took 30 years ago to make a fuel cell stack was very high, and it was a huge part of the cost. And so the technical development that's taken place in the last 30 years has lowered the amount of platinum in this MEA, this membrane electrode assembly, considerably, maybe 10 times less platinum. So the amount of money that you would spend on platinum in the stack in a fuel cell system has dropped a huge amount. The membrane is now thinner than it used to be because of technical development. And so the performance of the fuel cell is also much higher. The longevity of the catalyst itself has also been improved. They've learned how to make better catalysts over the last 20, 30 years. And so where the fuel cell may have originally lasted maybe 1,000 or 2,000 hours, and now they're getting 30, 40, 50,000 hours out of these stacks. And all of it's because of the technical developments. Things like these bipolar plates, these require coatings. And so people have learned a lot about the coatings over the last 30 years. What kind of coatings can we put on these? It turns out if you don't put a coating on these will corrode, and ions of iron or different things, they'll get into this membrane here and eventually ruin it. And so one of the things that people learned was we need to coat these plates, and we need to coat them with different kinds of things that make them really conductive on the surface when they touch, because we're running a lot of current through here. This right here would be 80, 100 amperes, which is a lot of current.
Wow.
People learned a lot about the coatings. They learned a lot about the catalysts, and then all the subsystems that go around it, pumps, blowers, all the balance of plant components. You can go out and buy those now. 30 years ago, they didn't have them. And so the challenges we faced a long time ago in this industry have been overcome with a lot of investment. A lot of government investment, a lot of private investment. Billions of dollars of money have been spent to figure all this out. And so one of the beauties is coming in here as a startup now is I don't have to pay for that. Somebody else paid for that, and most of it's off patent because it's
25 years
quite
or
some
more.
time.
Yeah.
Right. And so and all the research that got done delineated what the issues are. And so we know what we need to solve to make a good fuel cell. 29 years ago, 30 years ago, these we didn't know. We didn't know certain things. So those were the challenges that we faced over this period of time when I've been in the industry that enable us now to, out of the box, make a really good fuel cell. 30 years ago, the fuel cells really weren't that good. The membranes would fail, they would catch on fire, just lots of things because they weren't that good. The quality of these membranes was poor. And just a lot of things about the fuel cell have been improved to the point now where they're great. They work really well. They're reliable. They last a long time. And so we get to take advantage of all of this R&D that's been taking place worldwide and make our own improvements for our own IP, as well as take advantage of what's out there and take advantage of the suppliers. I can buy the membrane now. I can buy catalyst, and I can buy it very economically compared to what it would have been some time ago.
30 years ago. Yeah.
And so those were the challenges of getting to where we are today. And it's one of the reasons why it's taken us so long to get past the promise of fuel cells and into the commercial reality of fuel cells, because you had a period of time where people were excited about it, but the technology wasn't quite ready yet.
Quite there.
But now pretty much everything's getting solved, and the stuff works really well now.
Fair. So you mentioned a lot of things. The efficiency went up. The size, the thickness of membranes went down. The amount of platinum used in a fuel cell significantly dropped to the tune of, say, 90%, which has made fuel cells now generally economical. In your 30 years of experience, how much of that is actually your doing, right? So how much of that is actually you had a role in part or parcel to actually get there in that development? So what have you been doing in the last 30 years in terms of developing your experience on a membrane or the coating or the bipolar plates or the fuel cells as a system or manufacturing? Or was it more just sales and marketing focused? What was your focus in the last 29 years from a fuel cell perspective?
Sure. Well, I couldn't claim the fuel cell industry at large as a success because of me. I mean, there's thousands of people working on this.
Yeah.
And that's a good thing.
That's a good thing. Always.
I would say, my contribution was really helping both Altergy and Plug Power or rely on, Avista Labs. It was Avista Labs, rely on Plug Power, but helping them develop their commercial fuel cells. And I think I played a pretty significant role in getting these fuel cells working. There were some issues that needed to be solved in terms of cooling and things like that. And so I really feel like I did get to play a part in two companies' successful commercial introduction. And they were some of the first players of making and selling fuel cells. And so that felt good. Some of the other players, like Ballard Power and some of these other, they were making different kinds of fuel cells, which is a liquid-cooled fuel cells. So my early background and experience was with air-cooled fuel cells, but there's actually two kinds. You can go with liquid cooling for larger, heavy, high-power stacks, and you can go with air cooling, just like a car engine. The old Volkswagen Beetles, lawnmowers, those tend to be lower power engines, a little lower density, a little lighter duty. And then if you want to have a really like a truck, you've got to go with liquid cooling. There's just too much heat. And you're trying to squeeze all that power out of a really small stack. And so these plates right here, actually, you'll notice there's a difference between these plates. This has hydrogen and air. This big monster plate here for trucks, this has hydrogen, and it has air, and it has liquid. So here you've got a liquid-cooled stack, and you've got three passages that have to move those things in there into these bipolar plates.
And what liquid is that typically?
Typically, it's water, and then to prevent it from freezing, there'll be like a glycol kind of mix, a lot like your car. It has to be non-conductive, because if it was conductive, it would short the stack out through the liquid. And so you have to keep that, you have to run it through a little resin bed to pick up any impurities, because if I put salt in there, it would short out the stack.
Of course, yeah. It'll be conductive.
And that's yet another area where people learned, hey, we've got to put this little canister on the side here to keep that coolant to make it so it doesn't conduct electricity. And this is something that they learned over the last 30 years, and I can go buy that because people make it now for the fuel cell. And so all these little developments add up to being able to make and put together a successful stack. So I played a part in that. I've been involved in a lot of the different pieces of technical development that you need to have in a fuel cell. I've done electronics work. I'm familiar with the coatings. I'm familiar with the catalyst work. I'm familiar with making the MEA, designing the stack. So pretty much almost every aspect of the fuel cell, I've had a hand in it.
Great. So you spoke a lot about designing, the R&D work, the things that actually put one product on the table or one prototype on the table, but making that one prototype into 10,000 units a year, or maybe even 10,000 units a month, or even a day for that matter, manufacturing is a whole different animal. So could you say that you focused your time on R&D, or you focused your time on manufacturing, or was it both, or is it like hand in hand and one can't be separated from the other?
Most of my work previously has been more towards R&D, but I would say the last 10 years have focused a little bit more and more on production. My experience with Cytogen, I got a lot of good exposure into the manufacturing world of stamping these plates out of metal, and the coatings and the high-speed manufacturing processes. So, my journey has been one of, coming into a CTO role and then moving into a CEO role in my last position, and of course now. So my background is very technical, and that's important because you have to make sure you're designing and developing something that's going to be successful and doesn't have technical flaws.
Correct.
It only took an O-ring to take down the Challenger, I think it was.
Oh,
right?
yes, absolutely.
So little problems can be big problems, and it's really important to make sure the technology is good. But I've more and more gotten involved and exposure to the large-scale manufacturing steps, in China and such.
Right. So you can say 19 years was hardcore R&D, technical. 10 years was about manufacturing, and the last, I think, say 5 years, you stepped in as the CEO role, which was. The CEO is all encompassing, right? The CEO has to be involved with everything, the R&D, the manufacturing, the sales, the unit economics. It's a company that you're trying to run. So can you say that you've spent enough time in all key operations that take a fuel cell from an idea to a mass scale manufactured product and sold in the market, and that company runs successfully?
I would say one of the most important things in a management role is knowing that sometimes you're not the smartest guy in the room.
Yep.
And it's a fatal flaw with some places is where your leader feels like they're the smartest person in the room. My goal as a manager of people is to bring in really solid people, hopefully that know more than I do, and that's going to be more likely in the marketing area and the sales area, because look, I come from a technical background, so I want to be bringing in top salespeople and top marketing people and people that complement my skill sets, my natural skill sets, and make sure I listen very carefully to them, because it's the team that makes a company. You cannot be a one-man show. So it's my goal to transmit my technical knowledge to the staff, and then to bring in people who are really good at things that I don't have a lot of experience in. And so, yeah, the technology end, I'm very strong. And then, some of these other areas we bring in the people. And, the goal is to not be a one-man show. I do not want to do that. It'll burn you out.
No, absolutely. I don't think a team can be, or a company can be a one-man show. I mean, a large company has to have a team, has to have a lot of people. So I completely agree with you there. Close to 30 years in the fuel cell industry. Nice job roles at CEO, CTO positions across the globe. You've been in US, you've been in China, you've been in Malaysia.
Singapore,
and multiple roles there as CTO, as CEO. What was the top 1, 2, 3 things that made you say, okay, this is it, I need to start up my own again?
Sure. Well, I've been watching India for a long time. And I watch all the different countries and what they're working on. China's got a huge fuel cell hydrogen energy program.
Yeah.
Lots of work going on over there. And Europe has had a lot of work for a long time. And of course, Ballard, they came out of Canada, companies in the US doing things. But I've been watching India, and there's been a lot of really good work towards electrolyzers here.
Yep.
Very encouraging.
Yep.
And so I say, okay, we're going to make hydrogen here in India. That's good. But who's going to use it?
Yep.
I mean, sure, you can use it for steel or something like that, but I mean, use it for transportation or things like this. I just really wasn't seeing any companies coming in and doing, taking the leadership role in a fuel cell company in India. And,
true.
There's
There is a shortage.
1.4 billion people, and I didn't see a fuel cell company. To me, it was just shocking. So I just felt like, I really enjoyed having my own company and doing that. And I really felt like it was time to do that again. And, the chance to form maybe one of the first major fuel cell companies in India is something I just couldn't pass up. And so Transition Venture has been gracious enough to give us our seed round of funding, and that's allowed us to get into these facilities here and start up with a small team and get some prototypes built. And so I really felt like, now is the time for India to move into this technology. we can take advantage of all those years of development that other people paid for. I'm fine with that.
Which you did as well.
Yeah, I did it too, and put something together fairly quickly on a very low budget, and develop our own IP. You know, I've been developing IP for a long time, and typically I'll write the patent myself. And we've got about 4 or 5 patents that we'll be working on for our technology here.
Wow, multiple skills in one person. Like writing patents yourself also isn't something easy. All right. So so finally, what is Protonas? What are you guys? What are you guys developing? What are you guys building? What is your core IP or core product?
Well, a couple questions in that, so you might need to remind me if I miss one of them.
Sure, please.
So our goal as a company, as I mentioned, is to be one of the first premier fuel cell companies in India. And in doing that, we want to offer 4 core products. The first product we want to offer is a backup power system. And that's what this development is. That's our first development effort, is a backup power system. So what you see here would be anywhere from 500 watts to 2 kilowatts, depending on how large the stack is. And that would be for backup power applications in principally North America, because that's a good market for this. And I'm super familiar with it, having worked there and in that market. And so we really feel like this is going to be a great export product for us in backup power. And so think about traffic signal lights, emergency backup power, fire stations. All these need long-term backup power for, outages that can last up to, say, 72 hours. So that's number one. Number two, we want to develop fuel cells, either small size or big size, for anywhere from 3-wheelers up to potentially trucks or cars. And so those would be for motive applications. And so that's a big potential market too. Now that is dependent on the hydrogen infrastructure.
Yeah, definitely.
This backup power system, no, it's not. That can be using bottled hydrogen. And there's not very many power outages in the US. So your bottles might last 10 years. I mean, if there's not a lot out. So it's a different thing.
Sure.
You're not depending on delivery of a lot of hydrogen, where if you have a car,
sure,
you have to have refueling stations. So that's the second product, is motive power. The third product would be making a lightweight version of what's in here for a drone. We've been looking at what other people are making for fuel cell drones. And just parenthetically, a fuel cell drone can fly 4 times longer with the fuel cell versus batteries. So it's kind of a big deal to transition into hydrogen for a drone.
That's huge. Yeah.
It is huge. And if you're running this drone a lot, those LiPo batteries are very expensive, and they die after 200 cycles.
Right.
And so if you're running your drone every day, you can go through a huge amount of batteries, and it's very, very expensive.
Yep.
So there's two really big reasons on using hydrogen for drones. And so we think that's a big market. I mean, drones are really taking off, if you will. It's a multi-billion-dollar market. So
complete hydrogen fuel cells for emergency power backup for drones and aerial mobility, as well as EVs and ground mobility.
Right, but I've still got number 4.
Okay.
If you recall, we talked about methanol reforming. And we can build a small methanol reformer that will complement what would be in here. And then we can run this on a liquid fuel.
Okay.
And this is something I really know how to do, because methanol reforming, I've been doing that for 20 years or something. So methanol reforming is very familiar to me. And so we're going to be able to build a little mini methanol reformer system. And if you're wondering how big that market is, there's a company called SFC Energy in Germany. And they're one of they're selling 15,000 units a year with these methanol-based fuel cell systems.
Right.
15,000 systems a year.
Wow.
And they're highly successful. Last year, I think they made a $12 million profit. So there's a good market out there for the methanol too, a proven market. And when we run the numbers, we can just absolutely compete with them on cost. So those are the four markets.
So essentially, hydrogen fuel cell systems for mobility, for emergency power backup application, for aerial mobility and drones, and the addition of a methanol reformer, which essentially enables you to use a liquid fuel into the fuel cell system rather than putting in hydrogen as a gas, which makes it easier to use, easier to transport, and things like that. So, what sort of power ranges? You didn't talk about power.
Sure. So these smaller kinds of fuel cells that are air cooled, those are pretty good for anywhere from say a few hundred watts up to 3 or 4 kilowatts, something like that. And that's big enough, 2 or 3 kilowatts is enough to run a 3-wheeler in India. And a few hundred watts is good enough to run a traffic signal intersection. So that's kind of your smaller range. And that, as we get bigger, it becomes, it makes a lot more sense to go to liquid cooling and to build the stack that way. And so in a liquid cooled stack, using plates like this, you can build a car, a bus or a truck, or even a larger backup power system. And so that's what you would get with a bigger system like this. And so you basically have two kinds of technical differentiation. You've got your liquid cooled for bigger applications and your slightly less expensive, more simple air-cooled system for lower power applications.
Got it.
And so those would be our two basic differentiations on what we're doing.
Can you say 20 kilowatts and less is air-cooled and 20 kilowatts and plus is liquid-cooled?
No, I'd make it more like about 5.
5 kilowatts. Yeah. Okay.
Now, some of the drone guys, what they're doing is they're building 5 kilowatt stacks, but they'll put 4 of them together and run them in parallel on a drone. You can do that.
Okay.
And so they've got these drones. This Chinese company is making drones that can carry, I think, like 200 kilograms, something like that.
Okay.
And they've got 20 kilowatts worth of these stacks. They just put a bunch of them in parallel.
Can you compare the two? Can you compare air cooled as well as liquid cooled? What are the sort of advantages? Why can't we have a 100 kilowatt air cooled, or why can't we have a 2 kilowatt liquid cooled?
Well, you can. You can. It's a question of size and simplicity. The air-cooled stack have basically it's a little bit like a radiator. You've got the plates, and in between the plates you have a little fin thing in there, and then you blow air through it. And so that makes the stack quite a bit bigger. Where the liquid-cooled stack, it's just these plates put, so these are maybe 1.5 millimeter per plate, and these are going to be maybe, I don't know, 6 or 7 per plate. So this is going to be a lot taller for the number of cells. And, in a large air-cooled system, the stack is the radiator. And so let's pretend this is a truck.
Yeah.
You'd have this huge stack, because now it's really, really tall.
Yeah.
And that would have to be the radiator, so you'd have to stick it in the front of the truck.
Correct, for the airflow.
Yeah, and then it'd be high voltage, and it just really wouldn't work out that well. So in those applications, it makes sense to have the radiator in a convenient location on the truck, and the stack kind of in your engine bay, and separate those functions.
Correct.
Where with the air-cooled stack, it's all small. The air comes in here and blows through the stack and leaves to the other side.
Correct.
So that makes sense. It's not a big deal. And then the drones, you just blow air through it. And so there you can kind of combine them, and it works a lot better for that situation.
Got it.
So you have niches where one works better than the other due to different kinds of characteristics.
Got it. So, like you said, right, there are a bunch of other companies that are doing this. Various types of fuel cells have been doing it for the last 30 years. The industry, the technology itself could be about 50 years old. So what makes Protonas unique? Why is this any different from what's already out there in the market today?
Sure. We are developing and are preparing to file some IP, which does help us a little bit. One of them is for a really low cost coating. The coating can cost anywhere from $1 to $3 for, a plate like this. And a truck fuel cell stack can have 500 of these plates. So that's $1,500 just for the coating. So that's expensive.
Of course.
We think we can do the coating for about 10 cents a plate, which is really a lot, a lot of savings. So we've been working on a technology that we'll be filing a patent on fairly soon that allows us to get that coating very inexpensive. And the other thing is, if you're going to put a coating on one of these plates, you're talking about a $10 to $40 million machine, typically. If it's a lower volume machine, it might be $2 or $3 million, but you're talking about a lot of money. So we think we can do this with a machine that would cost maybe $150,000.
Wow.
So your capex to do it, and then the cost of actually coating the plate would be far, far less.
Would you care to put a number on it? How much lesser? Capex wise and cost wise, how much lesser?
Yeah, well, we think we can coat a plate like this for maybe 10 cents versus $1 to $2 or $3.
No, from a systems perspective.
Um,
If, say, your typical fuel cells in the market today are costing 100 rupees, what would your fuel cell be costing?
Well, it depends how many plates you have times $1 to $3. So, like I said, if you have a truck and you've got 500 plates, we can make that for $1,500 less than our competitor because of our coating technology.
Okay.
So that's one area that we're working on. Another area that we're working on is going to be a method to purge the hydrogen in a way that you don't have emissions.
Wow.
Some people don't realize this, but hydrogen is indirectly a greenhouse gas because it doesn't directly cause problems, but it reduces the rate at which you can tear apart the hydrocarbons in the atmosphere. And so if hydrogen gets emitted, it actually can allow other greenhouse gases to stay up there longer. And so we think it's important if we're talking about trying to go to net zero and all these things, if the whole idea is to reduce greenhouse gas effects, reducing our own emissions is an important part of that. So we have a piece of IP that we'll be filing for that. We also have a method for cooling the air-cooled stack in a way that can probably give us maybe another 10 to 15% performance improvements, and also allow us to operate in really hot or cold environments much better. And so this is an important part of our air-cooled intellectual property. So those are a couple examples of some of the IP that we're working on. And 10% improvement in performance means the stack now is 10% cheaper.
Yeah. Yeah.
So these things do matter in terms of our cost of systems and cost of goods sold.
Fair. So from a patent writer perspective, how many patents can you say form the technology or the competitiveness of Protonas?
We're going to have 4 key patents, and then maybe if we get some good experimental work in another area, we could get one in catalyst. That's going to be a little more risky. We'll see how it goes. But if we get that one, then we'll have 5. I do know how to make a lot of patents, but if you have too many, it gets too expensive.
Yep.
I remember walking into Ballard at their headquarters a number of years ago. They had this huge wall, and it just had patents on it. And the first thing I saw it when I saw the wall, I didn't go to myself. It's like, wow, look at all these patents. All I could think of was, God, how much does it cost to keep these alive?
Yeah, of course.
Patents are expensive.
Of course, yeah.
I mean, we can file them cheap, sure. But then once you get, like if you're putting them into Europe, it's thousands of dollars to file and maintain these patents. And so you have to be very economical and thoughtful on IP.
Correct.
Sometimes it's better not to patent because someone else might try to copy it in some country where copying is done.
So You talked about 4 key patents, maybe 5, leading to this product, which is a great product. But tell me more on how the product compares to what's out there in terms of cost, in terms of efficiency.
Sure. Well, as I mentioned, a lot of our work here is going to give us better performance, and better performance means we don't need as many cells,
Yeah.
and that means the stack costs less money, and so that certainly helps us along our way of getting to a much more competitive price. And our other advantages is being in India, and so if we look at what's out there in terms of cost, we see Ballard and PowerCell. 2 big fuel cell companies. They're selling their stacks at about $1,200 to $1,300 a kilowatt. The number 1 Chinese fuel cell company, Sino High-Tech, they're making and selling fuel cell engines at about $600 a kilowatt. And we feel that by making these here in India, that we can get our manufacturing costs down to about $150 a kilowatt, and that we can sell it at 50% margin in the $300 to $325 a kilowatt range. And so we're making very good margin selling it at half the price of the Chinese. If the Chinese want to come in here and try to compete and import their fuel cells here, they're going to have to pay tariffs on it.
Tariffs, yes.
So you've got double our price plus tariffs.
Wow.
So I really feel like situating here in India from a tariff perspective, obviously it's a good place to manufacture things at low cost. And then our advantages with IP, performance improvements, that we can come in and we can make money basically at half the price of our competition.
Wow.
So I think it's just huge.
Wow. So to sort of summarize, if I get this correctly, you're saying fuel cells in Europe are priced at about $1,200, $1,100 per kilowatt.
Yeah.
Fuel cells out of China are priced at $500, $600 per kilowatt. Your selling price at Protonas, the fuel cells are going to be priced roughly at $300 per kilowatt, and that includes a handsome 40-50% gross margin.
Sure.
And a lot of that, as you said, is attributed to the 4 key patents that you hold, and also being part of the Indian ecosystem.
Sure. And when we look at those kinds of numbers, you might naturally ask, it's like, well, if they're selling at these high price points, why isn't Ballard or PowerCell or the Beijing company, why aren't they profitable?
Yeah.
And part of this is legacy. As I mentioned, these companies, they start up in these high-cost locations, and they build up a very large team, a very expensive team, and you create this legacy cost.
Yep.
And it has its own momentum. And so these are all people that have to get paid. Big teams, they've been there for 10, 20 years, and it creates a lot of general and overhead expense on these companies.
Yep.
And as I mentioned earlier, a lot of the work's been done over the last 20, 30 years.
Correct.
So I don't need this huge team of engineers, working in Germany or some other high-cost location. All that work has been finished. So I just need a team of people that can help me with the electronics,
Correct.
mechanical, things like this. Great talent pool here in India, lots of skilled engineers and such that we can bring in. I get a lot of applicants for the jobs, and a lot of really good resumes that come in. So big talent pool here, and so our overhead in running the company is just going to be so much lower, and so we don't have to sell at a really high price point to support this huge beast of an organization that some of these other companies, you would think that the Chinese leader would be doing better, but actually, I've been to these Chinese companies, and a lot of them get a lot of state support, a lot of state money, and so they hire a lot of people. way more people than they need.
Yeah.
But because the money was free and, a lot of incentives, so they put big teams together.
Yeah.
And
yeah.
ultimately, those teams need to get paid with the price of the product.
Yeah. Yeah.
So even though China is in a lower cost location than Germany or the US or Canada, they're still struggling because they don't have lean teams. They've got all the state support and they've got all these people that need to be paid, and they're oversizing their teams.
Correct.
So
A lot of this is very, very interesting, very, very insightful CEO perspective, as I would say, and all of these perspectives are not very common out there. So personally, when we were talking, you said there are 4 key patents, and you can file perhaps 100, but that wouldn't be the smartest way of doing it. That wouldn't be the most economical way of doing it. And these are very counterintuitive pieces of knowledge that people don't really have out there building a deep tech company. So having a large team may not always lead to success. Having hundreds of patents may not always lead to success. Having large overheads and being placed in San Francisco may not always be the key to success. So all of these are very interesting insights that I feel make you more rounded. I mean, I wouldn't hear things like this coming out of a pure researcher or a pure research team. They would say, let's go all out and file as many patents and research papers as we can. But it's in the end, it's all about that fine balance. It's all about that fine mix of a good scientific concept, a good technology, putting it into mass manufacturing, and then finally knowing how to run a company. That's, I think, what makes a company successful.
yeah, and part of this is born out from my basically 15 years of having my own company with a partner in the methanol reforming that I mentioned earlier. You learn how to live on less when when you don't have a huge amount of investor money coming in.
Yep.
And that kind of sets the tone for how you operate. And so I've always viewed investor money as very, very precious because you're giving up your equity for it.
Yep.
And, if you blow through it, you might not get more.
Absolutely.
And we've seen this before.
And equity capital is known to be the most expensive form of capital.
Yeah.
And investors today are really starting to appreciate the frugality, capital efficiency, profitability, or a very clear path to profitability are things that we see as investors of all sizes are starting to appreciate today.
Yeah. I mean, the Silicon Valley unicorn culture was very corrosive because, these people, they go out and they'd get huge amounts of money and they'd all buy a Mercedes and, have a chef coming in making them meals, and they just blow through it like a line of cocaine, man. They just the money be gone because they think, well, we'll just get some more, and then the investors look at their performance and say, no, there's no more, and then they're gone.
Then they're gone.
Right.
Correct.
So when I talk about this round of investment, this A round, we're looking at raising around $5 million. My goal is to make this the last round, if we can, to try to get to market with these different products and to develop the products and get them out there, and also go for grants. Grants are great; they're free money, and see if we can get to profitability on this A round. That's my goal. I want to be profitable on the A round.
Correct. And that's a huge goal.
Well, and it's good for the investors too, because if I don't have to follow on with the B or C round,
correct,
that means there's no dilution.
Correct. Or you could even say being profitable with the A round and raising money then on your own terms. You don't need to raise money and you will not evaporate if the money goes 6 months delayed. And that, I think, sends a very powerful message.
And you raise an important point there, because sometimes you do need to raise money to grow faster.
Yeah.
Not because you need the money to make
to stay alive.
The P&L.
Yeah.
You could be profitable, but if you've got something good going, sometimes you do want to raise that B round so you can go faster.
Correct.
But I don't want to get to a B round because we're still losing money.
Still losing money. Yeah.
That's
And
my
I think-
goal. That's my personal goal.
And I think these are perspectives that investors are really starting to appreciate. But coming back, a lot of people think fuel cells are some obscure technology that never got off. Fuel cells were very, very expensive and used somewhere in space, aerospace, or some small niche applications. What is the market out there? Are fuel cells really used today? Where are they used? Because we don't see them, so it doesn't really catch our eye, right?
Sure. Well, and they haven't been in the public eye here in India very much. You've seen more of them in China and Europe and North America because there's just been a lot of money put into it. And so most of the applications that you see, there's two, maybe three areas where I could tell you there's really good applications. One of them is in transportation. And so they have fuel cell cars, they have fuel cell trucks, fuel cell buses, and these are in the market now. And as the hydrogen infrastructure starts to grow more and more and the cost of hydrogen comes down, you'll start to see more and more of those. But there's been a lot of really very good demonstration projects and such with trucks and buses and cars, and now for quite some time. And China is going really heavy into this. I mean, they've got, I think, maybe 50,000 cars on the road, vehicles on the road, fuel cells. So I'd have to check, but it's a big number. And the other application, the other two applications where we see fuel cells that have been used for quite some time now are the backup power. And this has been in North America mostly, with companies like Altergy. Plug Power right now is the main company doing backup power systems in North America. And they've been selling systems for 20 years for backup power. But they haven't sold as many as they could because they're too expensive. So we feel like that market's proven. They are selling systems probably 350 units a year. But the main issue there is just the cost is a bit high. So we feel that we can penetrate that market and do the same thing they're doing. But if we can come in cheap enough, we can start displacing a lot of other technologies besides just fuel cells. I mean, 350 units a year, 500 or whatever. I'm not too worried about that. I'm worried about competing with batteries or diesel generators and things like that. That's what I'm competing with. And then the third area.
Can you talk more about the backup power application? Like, what is the problem? Like, what is the product that you're trying to sell? Who will it go to? Who's your customer? Who will buy and for what?
Sure. So California is a good example. California makes it really, really hard now to put a diesel generator in. I mean, it's really horrifying, actually, what you have to go through to site a diesel generator. And so it's so bad now that people just don't want to do them. And I guess
is that regulatory? Is that cost? What is
it's
that?
regulatory, pollution and spill mitigation, and then checking the unit and logging the hours. It goes on, and it's very difficult. And so, the other alternative is batteries. And batteries work great if you have maybe a 1 or 2 hour power outage. But if you have a major power outage of something like 8 to 72 hours, something like that, a fuel cell works really well because you just have too many batteries. And batteries don't hold up very well, especially lead acid batteries.
But is that really needed? Do you really need 8 to 72 hours of backup?
Sure. Right now in California, when the wind blows, they turn off the power. They literally turn it off. And the wind can blow in Southern California for an hour, for days, actually. And so you've got traffic signals, you've got fire stations, you've got police stations. They need backup power, but they can't put in a diesel generator because it's just too painful. So the only option they have right now is either a fuel cell or a huge stack of batteries. And the lead acid batteries have to be replaced every 3 to 5 years, and these are expensive.
So are you saying that diesel generators is a regulatory challenge, and that is why, and lead acid batteries are expensive, and that is why fuel cells will work? Are fuel cells going to be far more expensive than lead acid batteries or diesel generators?
But we're comparing, your total cost of ownership with lead acid batteries over 15 years. If you're talking about 40 kilowatt hours of backup, you could be looking at $50,000 for a battery system. And so we literally crush it.
50,000 versus 15,000.
No, like I said, we're probably looking at about a wholesale price for a complete system, not just this. And we're talking about the cabinet that would have the bottles in it and everything, for somewhere around $6,000 or $7,000.
$6,000 to $7,000.
Yeah. So even if you marked it up with the supplier and it's maybe $9,000, we're way less than the other solution.
So from a total cost of ownership, the only prevailing solution for these small emergency power backup applications in the US, you're saying, is these lead acid batteries. And from a TCO perspective, that's a fuel cell is going to be, say, 70-80% cheaper.
Yeah. Now, lithium batteries compete a little better than lead.
Yeah.
They've been slow to catch on because they have a tendency to spontaneously self-combust.
Okay.
But one of your companies has solved that problem.
Yes, we have. Yes.
And that's another topic. But lithium is starting to displace lead acid. They need to be replaced anywhere from 8 to 15 years. So you may need to replace one set of batteries over the life, maybe not. Typically, a lot of these telecoms, they'll replace them just to be sure because they don't want an outage. So I would say the chances are they would probably replace them at the 8-year mark. And so, you've got some replacement costs. Not as bad as lead acid, but it's still, even if you have one replacement, this system just destroys it on cost.
Okay.
Yeah.
And what would be the comparative there? You said 50,000 for a lead acid battery, about say 8 to 10,000 for a fuel cell, a TCO for 15 years. What would be the cost for a lithium?
If you had to replace the lithium once, you're probably looking at maybe, I don't know, $24,000 or something like that. It's not as bad as lead acid, but it's still a lot more than what we would. Because look, a bottle of hydrogen 15 years from now is still going to be just fine.
Yeah.
It stores really, really well.
Of course, yeah.
And one of the reasons we're talking about this market is that most of these places, the average power outage a year in the US is 0.25 hours a year. It's
0.25
hours a year,
which is near zero.
Yeah. And so the only real power outages you have to work with are ones where you're worried about a hurricane. So this kind of system would be great for places that have hurricanes, an ice storm where the power lines go down.
And with the recent example of Spain, you see with renewables coming onto the grid is becoming even more unreliable everywhere, and that's globally. There are more downtimes that are coming about, and that's a lot to do with solar penetrating further, leading to a lot of disruptions, a lot of demand supply gaps, leading to a lot of disruptions and power outages.
Sure. The beauty of the North American market is that the system really doesn't have to come on very much. And so those bottles are going to last forever until you have a really bad event and you need them.
Yeah.
And so as opposed to other countries where, you'd have to replace those bottles constantly.
Correct.
This particular market in North America and probably Europe too, the bottles are a cheap way to store energy and they last forever compared to battery.
Correct.
And you don't hardly ever have to use them. And so the replacement of these cylinders is nothing you really have to worry about. You might have to replace them maybe once in 15 years.
And by nature, what a fuel cell and a diesel generator has in common is that these are energy scalable systems. So if there is a power outage and that lasts for days, you can just bring more bottles of hydrogen. Whereas in a battery pack system, you can't really do that. You'll have to add more battery packs to increase the energy backup capacity.
Well, both of them at a certain point become a little ridiculous because, bottles of hydrogen, they're kind of big.
Yeah.
And so if we need to get out to a month of backup power, the number of bottles we would need would get kind of crazy.
Yeah.
And this is kind of where that little methanol reforming system would work.
Come in. Yeah.
So let's say you have a traffic signal light that needs to be able to go for a month or something really crazy. If you have a methanol system, that can keep it going for a really, really long time.
Yeah.
And so if you have really sensitive locations that need a super long time of backup power, that's where our methanol system's going to be great. For example, places up in the mountains where they get snowed in for the winter, our system would be great for that because you can't drive in there and refuel anything. So you need something super reliable.
Fair.
And that works really well. So there's all kinds of applications for this technology.
And then finally, what is the sweet spot? A month is too long. An hour is perhaps too short, and that can be taken up by a lithium cell. What is that sweet spot, and does that sweet spot really exist today?
Sure. No, it absolutely does. A lot of places, they need 8 hours of backup for emergency services, and some people require even more. And so you've got this window from 8 to 72 hours that gets very, very expensive to fill with batteries. And so that for us is kind of the sweet spot, somewhere around 50 to 70 kilowatt hours of backup power, anywhere from 4 to 6 bottles of hydrogen. Any more bottles than that, it gets a little unwieldy.
Yeah.
So for us, the cabinet with the 4 bottles or maybe even 6 bottles, that's a pretty good fit for what we're doing.
Yeah.
And that hits the long-term backup power sweet spot.
Yeah.
And if you need to go more than 72 hours, that's where other solutions like our little methanol system could fit for that.
Got it. Oh, very interesting. And this sweet spot, is this 8 to 72 hours? Is this something that you think will come on in the next 3 years, 5 years, or is that market already there? Is that need already there? And is that need through a regulation, or is that an inherent need?
Working backwards, the regulation does help us because a lot of emergency services are now being routed through the cable going into people's homes. So it used to be a phone line, and you call 911 on the phone line, but now it's going through your cable. And so some people are saying, hey, that cable system needs to have 8 hours of backup because people can't call 911 emergency number if the power goes out, because the power for phones is separate from the grid in the U.S. So the power goes out, you can call somebody. But if the power goes out, the cell phone towers go out after about an hour or two because they don't have very much backup power. So there is a stipulation that they may require 8 hours of backup power for some services like this. And that works in our favor. So regulatory will always push it in our direction, where they're saying, hey, we need more backup power. That moves us into that sweet spot for sure. What was the other part of your question again?
Is this a regulatory need, or is this an inherent need? Like customers realize that I need to have 8 to 72 hour backup.
Sure. Yeah. And so I mentioned there's municipalities and power companies and all kinds of companies that they've just got to have something in the event of a hurricane that keeps them running. And these can be fairly small needs, like a radio system for a fire station or a little power system. These substations, electrical substations, when the power goes out, they need something running so that they can turn back on. So there's all kinds of applications where people need more than 2 or 3 or 4 hours of backup power. And this is a much, much lower cost solution for that market. And the fact that they've been selling into these markets now for 20 years in very modest volumes tells me there is a market. People will buy this at price points way higher than what we want to do. Even if we took all their business away, that would probably be enough to make us profitable.
Power backup scenario, I would guess that it's not only about the cost, right? How easy or how hard would it be for a startup, upcoming startup like yourself, to actually break into this market?
Sure. So we've got, obviously any startup has options for how to go to market.
Yeah.
Now, we know a lot of people in the backup power industry in the U.S. Just through my colleagues and associates and previous business. So there's two different ways we can go in attacking that market. One is to find a market channel partner, which is my preferred way of doing it. Somebody who's already doing installations.
Yeah.
They already have crews that go out there and pour the concrete, put the conduit in, get the stuff put in.
Fair.
I want them to be my market channel partner, and to sell it to them wholesale. And we'll even brand it for them. If we want to, do it for APC or for Intersys or one of these big players. It's one of these big players in that market. That to me is our number one choice. Get somebody out there who's already putting backup power systems in, offer them a better choice, and tell them, hey, we'll even brand it for you in your name and sell it to you OEM wholesale prices. That to me is the best situation.
Yeah.
We could also,
would sitting in India be a disadvantage going to US for an emergency power backup application?
Well, if we have to set up and actually be the team that does the installations in the US, it's going to get expensive for us to set up teams over there that do this.
Yeah.
And so that is not our preferred route. And our first route is to try to find market channel partners that'll work with us over there.
Okay.
We think we can.
Got it. And in your earlier experiences, you have also sold power, hydrogen fuel cell solutions in this market?
Through Altergy, yes.
Okay.
Yeah.
Right. So that gives you an understanding of the landscape. That gives you an understanding of the go-to market, what sort of unit economics, service agreements, all of that. What sort of agreements would work here?
Oh, absolutely. Yeah. I've got access to all the old Altergy employees and everything that they know, and so I've got a kind of a knowledge base we can tap into with a little bit of consulting. Because Altergy, unfortunately, didn't make it. They just had, their burn rate was $500,000 a month.
Wow.
Operating in California.
Yeah.
And they just couldn't keep the company alive. They were able to sell products and they were fine and people liked them. But, it's the same problem I mentioned earlier. Their general and overhead was just so high, being in California, they couldn't make it. And so we'll be able to sell it at a much lower price and make it and do quite well as a company. Because, we want to sell these at 50% margin at even lower prices than they were trying to sell them. And we can be a highly profitable company doing that. But
Got it.
And so,
Got
yeah.
it. Got it. And so that is your first application that you target. The second application you also mentioned was drones and aerial mobility. Talk a little more about that.
Sure.
What are you replacing there? What is your value proposition there? Cost, efficiency, flying time?
Well, as I mentioned, the two big advantages going to fuel cells are flying time, which is 4 times better. And the cost is better if you're flying a lot because you're saving up on batteries. Now, if you only occasionally fly it for recreational use, you're probably better off with batteries. But for military applications, being able to fly a drone 4 times as long is a big deal.
Of course, yeah.
So we think actually the military might be very interested in us being able to build a good military type drone for India. So really our value proposition will be to work closely with some integration partners. We don't build drones. I don't want to build drones. There's lots of companies, lots of startups doing just a fantastic job of building drones.
Yep.
So we want to build a power pack, an OEM power pack that could go into a drone. And we think the best way to do this, start out with maybe 2 or 3 companies in India that we can work closely with that are interested in what we're doing and engineer some systems for them and get our experience that way, working directly with our customers. And that'll give them familiarity with what we're building and developing for them and give them the confidence that this is going to work.
Yeah. And there's a huge push for a lot of innovation in defense. As you see the global scenario, everyone wants to innovate in defense. Everyone wants to have their edge in defense from a nation perspective also.
Yeah.
So, yeah, that's very interesting. In a drone, though, when you say you have 4 times the flying time, what is that compared to? Is that a battery powered drone, or is that a
It's compared to
diesel
battery powered
generator?
drones.
Okay.
Yeah, battery powered drones. Yeah.
So from an overall flying time perspective, you are 4 times the flying time. But from, how would you say, from a cost or a weight and volume perspective? Because obviously in drones, weight and volume is key. So weight and volume compares your fuel cell to a battery pack or a diesel engine. What is the weight volume mix? What is the cost mix? And what is the flying time mix?
The tank does add some space. You've got a little hydrogen tank on top.
Yeah.
And so in our presentations, we've got a picture of this, so you can see it. The drone has this kind of little cylinder on the drone.
Yeah.
And so that does add some weight. In terms of cost, it's going to be more expensive than batteries, but it can do more. And if you run it a lot, it's going to save you money. So it just depends on your need. Like I said, if you're just a weekender, just go get a battery drone.
Yeah.
If you absolutely have to have the extra range, or you just have to run this thing every day, like for agricultural, like they're making drones now that spray crops.
Yeah.
You're going to burn through a lot of batteries spraying crops every day, all day long.
Yeah.
So that's a non-military application where the cost of batteries is a huge part of your TCO on making a fuel cell drone. So we want to develop relationships. To me, one of the successful parts of starting up and doing a company and running a company is it's about relationships. So we want to form relationships with some drone companies and build trust.
Yeah.
Because that's where you get the business.
Yeah.
You don't just do something off on the side and then say, okay, well, here it is. You can, but I would much rather over time work with people and develop deep relationships with their staff, with their engineering teams, working together. This is my vision for how we get into the drone market, is by working closely with companies. Because at the end of the day, doing business is relationships.
Fantastic.
I've seen companies fail
Yep.
where they just were nasty to get along with.
Yeah. Yeah.
And people didn't want to do business with them.
Just didn't want to work with them.
And entire companies got destroyed because they were just nasty to work with.
Yeah. Yeah. Yeah.
So I think it's a huge part of your business. It's not just a spreadsheet. It's not just, a presentation or a product. It's about getting to know people,
Fantastic.
developing trust, developing
Absolutely.
relationships. I think that's the most important part about getting into our markets, actually.
Yeah.
When we talk about like these big fuel cells for buses or trucks or cars, that means that's a relationship that we need to have with a company.
Yeah.
They need to trust us. They need to know that we're telling them the truth and that we'll work through any problems. And if there's a warranty issue, that we'll stand behind it.
Yeah.
They need to trust us.
And these are some of the undervalued things that an experienced team brings. Obviously, there is the core expertise of building the technology, but knowing the people, knowing how to get things done, knowing how to get things manufactured and sold are undervalued pieces of the experience that truly experienced folks like you bring to the table.
Yeah, and in our hiring process, one thing that we look for is people that get along with other people. I look for those relationship skills because if our team doesn't have them, we don't have a company, because I won't be able to sell anything.
Yeah.
Because people won't want to talk to us or work with us.
Fair.
So it's super important.
Fair. So to sort of summarize, core control on the complete fuel cell stack, be it the electrochemical piece, the electronics, the power electronics, the controls, core control on the fuel cell stack, and deliver it for applications in emergency power backup, in aerial mobility, in electric ground mobility. Is there anything I missed?
Yeah, there is. something really important here in terms of getting costs down, and that's vertical integration. You know, we're developing our own electronics. We're going to make our own bipolar plates. You know, we're going to stamp them ourselves. We're going to coat them ourselves. We're going to make our own MEAs. You know, we've purchased recently a huge amount of equipment for making high volume MEAs. And then we cast these parts. And so all the pieces that go inside our box need to be made by us as much as possible and controlled by us. You know, if we're going out of house for a lot of things, they're getting that percentage of margin instead of us. And so if we want to be a high profit company, we need to own all of these processes internally. And that's something I can help the team with because I've got experience in each one of these facets. And so as we continue to hire and get all of our equipment in place and the teams get trained, we're going to have the core expertise in each one of these areas and vertically integrate as much as possible. You know, we're not going to make some things that are hard to make, like carbon paper. I mean, you can't make everything. You know, we're not going to make transistors. There's some things that you just buy. But a lot of the key core things, we're going to make ourselves and control ourselves. And that's one of the secrets of how we're going to keep our costs down.
Fantastic. So where are you today? What have you achieved? What does this represent? And finally, where do you see yourself as a company, as an organization in the next 3 years, 5 years?
Sure. Well, obviously we've got this, and as of today, we're working on getting our initial stacks up and running and in this box, and a lot of testing, things like that. We're working on perfecting the electronics that go inside, and so I would say over the next 6 months, our goal is to get all the electronics work inside complete, get all the issues of building it and assembling it and learning how to run it just right. Because you've got to tweak the control system and program it in C, and we'll have to get our touchscreen display, all programmed and stuff. So there's engineering work.
Minor engineering work. Yeah.
And so I'd say that's a good 6 months, and then we're going to want to test the heck out of this thing. Because you don't want to ship something that has any kind of problems.
Of course.
But I think if we can, and this goes back to the relationships, if we can find some friendly partners that say, hey, we'll test it, and it'll just be between us, and if it has problems, you'll work with us and we'll get them fixed. But some early adopters that are friendly, where we can get these out in the field, see if there's any issues, fix them, and then we really go to market. So I see that taking about 1.5 years, maybe, and then we'll have everything worked out and can really start going to market with it.
Right. So the tech risk is largely taken care of. The tech is there, it's developed, the product is there, it's working. Now it's just a function of ruggedizing it, testing it thoroughly, because obviously these are critical systems and need to work perfectly at the customer's perspective. So
yeah, I mean, you have to put them on like you know what a shaker table is.
Yeah, exactly.
Yeah, they stick it on there and it goes
shake it, correct.
We need to do that.
Yeah.
You can't just build it and ship it, because you put it on a shaker table and a lot of things you thought were good are like, oh boy, we've got some work to do, because brackets get ripped off and all kinds of horrible things happen, right?
Everything happens, yeah.
And so, I mean, we try to design it for as good as you can, but you put it on a shaker table, and so that little things like this, we need to get it through codes and standards.
Correct.
And there's tests that you have to do to meet codes and standards. So these things do take time, but they reduce your liability, reduce any chances for warranty returns, and gives you a better start when you do go out there, because sometimes you only get one introduction, and so you need to make sure that
that one introduction works.
Look, as an engineer, I tend to be more risk averse, and engineers, they want to test it for 1,000 years. They don't want to release it. So the midpoint to me is a friendly party that they'll do some field testing with you, and get it out of your hands.
So perfection is the enemy of good enough.
That's right. So we'll find the right balance for that. And so that's our first basic core product. We want to focus on this right now and get it going. And then in the meantime, we'll work on the other products that we've talked about. You know, the big stuff. We'll get all that going, and we'll get the drones going and the methanol reforming system. But we don't want to lose focus on this first. You've got to have something out there.
Yep.
Because if you get too many things going and you don't, you know,
you spread too thin.
You spread too thin. So right now, keep our focus here.
Yeah.
As we feel like we're getting this done, you know, and then, you know, you've got a product life cycle management team.
Yeah.
And then as this goes out the door, now you can get your next project going.
Yeah.
And so that's what we'll do is, well, obviously with an A round, we'll have a lot more engineering resources, and we can staff up, you know, an electronics team. We can staff up an automotive fuel cell team. We can step up, you know, so those are all parts of our.
Correct. So, and this ties back to the capital efficiency point that you made earlier. So with very little amount of money, you've been able to make something that works. You've been able to prove a very strong point, that is a significant cost reduction, even up to 70-80%. Compared to Europe, and 50% compared to China. So this product here, it works, it's low cost, it is ready to go to the emergency power backup application with the understanding that it gets tested thoroughly and becomes robust and ruggedized. And that's I think what investors, what every stakeholder of a company is looking for: a good capital efficient company which has either profitability or a clear path to profitability.
Yeah. And I think these, if you think about it, these are fairly incremental.
Yeah.
Even getting your product to market, you know, it's not, everybody wants to see that hockey stick, you know.
Yeah.
And you know, I've been in presentations where I've seen people doing the hockey stick, trying to get investment money, and I knew it wasn't true. Mm-hmm. It's like, no, you're not going to go that fast. Yeah. Because you got to do this, and this.
And hardware takes time.
Yeah. So you know, my profit and loss calculations, you know, going into this A round presentation, they're pretty modest because I know these things take time, but these things take time because relationships take time. People trusting your equipment, and to the point where they're going to order 1,000 of them. You know, no one's going to just walk in the door, because fuel cells are, to some people, fuel cells are new and scary.
Yeah.
Right? And so they're going to buy 10 of them and see how they work for a while. And if those go great, then they'll buy maybe 50, and then later on they'll buy 100, and then 1,000. Yeah. But, you know, new technologies sometimes take a little bit of time to get the traction. But I do see these markets as huge. I see this as, you know, really breakthrough technology in some niches, and those orders could become quite large in the future. But like I said, these are business relationships. And people need to see it in the field. They need to get the confidence before they order 10,000 of them.
Great. Yeah. Great.
So we've had a nice talk about a lot of different things, and so, you know, people watching the video, obviously you're watching the video, and I'd like to invite you to come to our facilities here south of Chennai. They're fairly modest. This is seed money, but we would love to show you what we've been working on and give a demonstration of the fuel cell, have it up and running by then, and meet the team members, see who's working on it, and get a chance to see everybody and see the hardware. We'd love to have you come.
Thank you so much, David. Thank you so much for having this talk. It was super interesting, super insightful. Thank you for taking the time.
All right, and thank you for listening.